Do you know why the area of a triangle is equal to 1/2 the base times the height? I'll use some simple geometry to show you how to get this formula and also show you other ways that you can compute the area of a triangle. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. Here's how to compute the area of a triangle when the base and height are known. Our base and height of the triangle are also the lengths of the sides of a rectangle, and the area of that rectangle is equal to base times height. If we look at our red rectangle, we can see that it's made up of 2 small triangles and 2 bigger triangles. So we can say that the area is 2 small triangles plus 2 big triangles. If we look at our blue triangle, we can see that it's made up of 1 small triangle plus 1 big triangle. So this is equal to 1/2 of 2 small triangles plus our 2 big triangles. Our 2 small triangles plus our 2 big triangles is equal to our base times our height. So the area of our triangle is equal to 1/2 the base times the height. We'll highlight this formula. We can also compute the area of a triangle when we know 2 sides and an included angle of the triangle. Our 2 sides are A and B, and theta is our included angle. We'll start with the formula that our area is equal to 1/2 the base times the height. The base is A, which we know, but the height we do not know. Since we don't know the height, we need to write it in terms of our known quantities, A, B, and or our included angle theta. We know that sine of theta is equal to the opposite side over the hypotenuse, so that's equal to H divided by B. If we solve this for H, we get H is equal to B sine theta. This gives us the formula, our area is equal to 1/2 AB sine theta. Let's now find the area of a triangle when 3 sides are known. The sides are A, B, and C, and this is also known as Heron's formula. Let's start with the formula that we just found if we know 2 sides, A and B, and the included angle C. Since we don't know angle C, we need to find a way to express sine of angle C in terms of the sides A, B, and C. To do this, we'll first replace sine C with cosine C using the Pythagorean identity, and then we'll replace cosine C with A, B, and C using the law of cosines. Here's our formula from the previous page. To replace sine C with cosine C, we need to have a sine squared C, so we'll square both sides of the equation. We'll then replace sine squared C with 1 minus cosine squared C. To find just cosine C, we'll replace 1 minus cosine squared C with 1 plus cosine C times 1 minus cosine C. We'll then write the law of cosines in terms of cosine C. We'll do some algebra to solve for cosine C, and we'll get this expression for cosine C. Doing a lot of algebra, we find that 1 plus cosine C is equal to this expression, and 1 minus cosine C is equal to this expression. We'll then substitute these expressions into our formula for A squared. We can see that our A squared will cancel with our 2 A's down below, and our B squared will cancel with our 2 B's down below. Let's also note that we can rewrite 4 as a 2 times a 2, so each of these 4 expressions can be divided by 2. We'll then call A plus B plus C divided by 2 S, which is the semi-perimeter or 1/2 of the perimeter. If we do some more algebra, the other three expressions are equal to S minus C, S minus B, and S minus A. This gives us a nice formula for A squared. If we then take the square root of both sides, we end up with Heron's formula. This is a great formula to use when you know all three sides of the triangle, but you don't know any of the angles. We'll now look at a formula for the area when two angles and any side are known. Let's make a note that if we know angle A and we know angle B, we can also find angle C since all three angles add up to be 180 degrees. Our strategy is going to be to write the area of our triangle in terms of angle B, angle A, and angle C, and then combine these formulas into one where we have all three angles and only one side. We'll let that side be equal to C. From one of the previous formulas that we found, we know that our area can be 1/2 AC sine B, it can be 1/2 BC sine A, or it can be 1/2 AB sine C. In our first formula, we can solve for A, and on our second formula, we can solve for B. We can then substitute these formulas into our formula for the area that's equal to 1/2 AB sine C. We can do some algebra and cancel out one of the areas and some of the twos. This leaves us with this formula, and then if we solve for area, we have our final formula that's written in terms of all three angles and one side. I thought it would be nice to have all four of these formulas in one place, so I've summarized them here in this red box. I hope that you found this video interesting and you can now think about the area of a triangle in many different ways.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.